In this video, we're going to be going over the review for the Chapter 5 mid-chapter test, which is 5.1 through 5.4. Number 1, we're asked to simplify this expression. So as we go through the order of operations and process, we need to evaluate the cube on the outside of that first group. The cubed on the 4x to the third y is going to apply to each factor. So the second step in simplifying should look like this. This will become x to the, this is a power to a power, that'll be x to the 9th, that'll become y to the 3rd, and then it will be multiplied by the 2x to the 4th y. That one will not change because there is no exponent there. In the next step, we'll need to evaluate 4 to the 3rd is 16 times 4, which is 64. We also have a times 2, and then we'll also multiply x to the 9th times x to the 4th. We'll add the exponents in that situation, the x to the 13th, and then y to the 3rd times y will become y to the 4th. You implied 1 there, so 3 plus 1 will give you 4, and then we would need to finish out the simplification by multiplying 64 times 2 be 128, x to the 13th, y to the 4th. As we simplify number 2, there are no exponents on that group of parentheses, nor this group, but we do have to deal with the negative, the subtraction, which is going to affect the sign of all of the terms to the right. The first quadratic won't change. The second one will become a negative 3x squared minus 4x minus 7. If we group the terms that are like each other, it would be an x squared minus a 3x squared, and then we would have a 2x minus a 4x, and then a minus 5 minus 7, and that would become negative 2x squared. That would, the middle two would become minus 2x, and then that would become minus 12. Problem 3, we need to find p of negative 5 when our function p is defined as 3x squared minus 4x plus 7. So negative 5 will be what we substitute in for x. Simplify the next step, it would be 3 times negative 5 squared would be 25. And then negative 4 times negative 5 would become a positive 20. And then a plus 7. That would become 75 plus 27, which would be 102. So p of negative 5 is equal to 102. Problem 4, we're asked to find the degree of this polynomial. We have 4 terms. The term with the largest coefficient, with the largest exponent is going to be the negative 5x to the 5th. So the degree would be 5. The leading coefficient would be negative 5, but the degree is just 5. For number 5, we're asked to state the number of real zeros of the function. In other words, how many times does this function cross the x-axis? It crosses it here. It tries, but it doesn't get there in the middle. And it crosses again here. So this will have 2 real zeros. In number 6, we're asked, what does f of x do? In other words, what does the y value do? What does the graph do, up or down, as the x goes to positive infinity? That's to the right. What does this graph do as we go to the right? This graph is going to increase as we go to the right. So it's going to go up, which means we're going to positive infinity. For number 7, we're asked to use a table of values and graph the polynomial, negative x to the third plus 2x squared plus 3, and then determine where those zeros are located and between what consecutive integers each real zero is located. So we would first go to the calculator and type in our equation into y equals negative x to the third plus 2x squared plus 3 negative x to the third plus 2x plus 3. Double check, make sure I typed it in right. Negative x to the third plus 2x squared plus 3. Go to our table of values. And we're looking for a sign change in our y values. There's a sign change here between 3 and negative 6. And then it keeps getting larger. We go up. It keeps getting larger. So the only sign change we have is right here between 3 and negative 6. So our 0 is going to occur somewhere between 2 and 3 on the x-axis. Here are the values that will actually fit somewhat on our graph. Negative 1, 6, there's 4, 5, that's going to be about right here. 0, 3, 1, 4, 2, 3, and 3, negative 6. So our graph is something like this. So the only 0 we have is again here, somewhere between, here's the 3 line, somewhere between 2 and 3. Number 8, we're asked to use long division. Long division would put the t plus 2 outside of the t cubed minus 6t squared plus 1. And that would, dividing, we would need to make this a t squared, so the t squared times t would be t to the third. T squared times 2 would be a positive 2t squared. When we subtract, we get a 0, those cancel, and we get a negative 6t squared minus 2t squared would be a negative 8t squared. Bring down the 1. Did forget to include the 0t plus 1. So we bring down a 0t. I can't skip a degree. Then we will need to multiply this t by a negative 8t in order to, negative 8t times t is negative 8t squared. And negative 8t times 2 is a negative 16t. And so when I subtract here, I get 0 again. And 0 minus a negative 16t will be a positive 16t. Bring down my 1. I'll need to multiply just by a positive 16 times t would be a 16t. And then 16 times 2 would be a 32 positive. So when I subtract, I get 0 again, and then 1 minus 32 will be a negative 31. That's my remainder. So it's going to be a minus 31 over what I divided by t plus 2. So to write the answer out, it would be the t squared minus 8t plus 16 minus 31 over t plus 2. Synthetic division can do the same thing. It's a little less messy. With synthetic division, we would want to write the opposite sign of the constant on the thing I'm dividing by. So it'll be a positive 4. And then I'll need to write the coefficients on the decreasing degree of my terms. So it'll be a 1, negative 8, 19, negative 9. Draw my line. Under this last number is going to be my remainder. So the process is to first bring down the 1 below the line, and then take the 4 times the 1 and put that result here. Negative 8 plus 4 is negative 4. Then I take the 4 times the negative 4, and I get a negative 16. And when I add, I get negative 3, or I get positive 3. And then last, I take 4 times 3, which is 12. And that gives me a remainder of positive 3. So that means my answer will be this is going to be the x squared. This is going to be x to the first. This is going to be plain old 3. And that number is going to go over the x minus 4. So it'll be 1x squared minus 4x plus 3 plus 3 over the x minus 4. Number 10, I'm asked to simplify, so I can either use long division or I can use synthetic division. I prefer synthetic division, so in this case I'll have a positive 1, opposite sign of that there, and then starting with p to the third, I have 1 p to the third, I have 0 p squareds, I have 0 p to the firsts, and then I have a minus 6. I have to include all the decreasing degrees. My remainder will be down there. I'll bring down my 1. 1 times 1 is 1. Add, I get 1. 1 times 1 is 1. Add, I get 1. 1 times 1 is 1. Add, I get negative 5. So my answer will be 1x squared plus 1x plus 1 minus 5 over the p minus 1. Number 11, simplify. This is just simply FOIL. X times x is x squared. X times negative 2 being negative 2x. And 5 times x is 5x positive. And then 5 times negative 2 being negative 10. The two middle terms will combine for a positive 3x.